most definitely.
So guys, what are we doing with these videos?
Well, you and I are going to talk about circuit breakers. And we're going to talk about something a lot more exciting than that, but we're going to talk about contactors.
Well, I got fuses, and you guys know all about fuses. We protect circuit breakers and contactors all the time.
Whoa, this is not a competition.
You mean like the overcurrent protected device games?
Well, breakers would win. No way, contactors have it all day. The endurance is there.
600 volts, 300,000 amp interrupting rating, and current limiting. Come on.
Well, I think we should talk about the different types and applications for all these products, but for breakers, I think we ought to focus in on the new capabilities of the power.
Yeah, we're going to start with the basics, but I think we should definitely talk about the power defense.
So what is a circuit breaker and where are they typically applied on electrical power systems? UL 489 defines a circuit breaker as a device designed to open and close a circuit by non-automatic or manual means and to open the circuit automatically on a predetermined overcurrent without damage to itself when properly applied within its rating. They provide feeder and branch circuit protection for wiring and are designed for overcurrent protection for overload and short circuit conditions. There are many types and sizes of circuit breakers used on power systems, from residential to large industrial and utility systems. Basically, you can categorize circuit breakers as either thermomagnetic, designed to trip on their own during overcurrent conditions, or circuit breakers that trip when another device like a relay or trip unit tells them to trip. The more advanced breakers can have many adjustments and settings that offer better coordination and selectivity with other protective devices. We will focus this video on 4 types of circuit breakers: miniature circuit breakers, molded case circuit breakers, insulated case breakers, and power circuit breakers. Let's make this simple analogy to compare breaker types. A 20 amp thermomagnetic residential breaker is like this small non-adjustable wrench. You get one size and it'll work well, but it has no adjustments. We call these miniature circuit breakers. The next type is also a thermomagnetic breaker called a molded case circuit breaker, or MCCB. They're used for commercial and some industrial applications, and these breakers would be like this adjustable crescent wrench. The maximum size is set, but you can adjust it down for smaller size settings if needed. Finally, the more advanced MCCBs, insulated case and power circuit breakers, could be compared to this socket set. There are many protection adjustments and almost unlimited flexibility for settings.
Generally, when you think of switching power circuits, you may think of circuit breakers or contactors. So what's the difference between a circuit breaker and a contactor? There are many different types and sizes of each, but in general, a circuit breaker's primary function is to interrupt circuits during fault conditions or overload situations. A contactor is primarily used to turn on and off loads or control equipment. While breakers are designed to interrupt fault current, a contactor can trip during an overload condition, but if you tried to interrupt a fault with a contactor, you would likely weld or damage the contacts. Another significant difference between circuit breakers and contactors is that while you can easily turn off a breaker electrically, manual intervention is often required for turning a breaker back on. In addition, circuit breakers are typically designed for 10,000 operations, and contactors are designed for 1 million. But since breakers aren't really intended for many on-off cycles, 10,000 operations is significantly more than would be required in its lifetime. A thermomagnetic breaker has both overload and fault protection. To make a contactor have the same protection, it would require a thermal overload relay and a fault clearing device like a fuse or a special protective device called an HMCP installed with it. This is typically the case in motor control buckets. Let's discuss different types of circuit breakers, starting with a miniature circuit breaker. You would typically find a miniature circuit breaker like this one in a load center in your house or a panel board in a school or a hospital. They come in various sizes in single, 2, and 3-pole configurations up to 100 amps. Eaton's residential breakers are CH and BR plug-on breakers that physically plug onto the bus in the load center. Our commercial miniature breakers would look like these bolt-on BAB 120 or 208 volt breakers used in commercial or industrial panel boards, or these GHB breakers used on 480 volt lighting and control circuits. These require a bolted connection onto the bus in the load center or panel board. The size of the breaker is indicated by the handle rating, like this 20 amp breaker. Basically, a miniature breaker has a fixed trip curve like this one. A 20 amp BR breaker would trip in about 1,000 seconds for an overload slightly higher than its handle rating, but would trip in milliseconds for a fault condition. These breakers can interrupt fault currents typically up to 10,000 amps or 10 kiloamps. Molded case breakers and insulated case breakers like these power defense breakers and NRX breakers are available in much larger sizes ranges up to 1,000 volts and more than 2,000 amps. These breakers can interrupt higher fault currents depending on the model, even up to 200,000 amps. MCCBs are used in many types of applications in standalone enclosures, panel boards, switchboards, motor control centers, and busway. Basic MCCBs are very similar to miniature breakers in that they aren't adjustable. Some have instantaneous settings and others have additional advanced settings for long time pickup and delay, short time pickup and delay, and ground fault. Insulated case breakers are often used in larger applications like healthcare and industrial. Power circuit breakers are designed and engineered specifically for use in low voltage and medium voltage switchgear. The low voltage breakers are available up to 600 volts and 6,000 amperes and up to 200,000 amperes of fault current. And medium voltage breakers are available in 5 kV to 38 kV and 600 to 6,000 amperes. These power circuit breakers have many mechanical parts that need to be exercised, lubricated, and maintained. Most, but not all, are draw-out breakers. All power breakers require some type of additional intelligence to operate. For low voltage breakers, this is typically a trip unit installed in the front of the breaker. Trip units may include long, short, instantaneous, and ground fault protection. They may also have arc flash protection built in with a maintenance mode setting. Eaton's low voltage power circuit breakers are these Magnum and NRX breakers. These breakers use either Digitrip or PXR trip units. For medium voltage, protective relays are used. In many medium voltage applications, multiple protective relays or a multifunction relay is required for overcurrent protection. Relays also offer many other protective modes like undervoltage, overvoltage, synchronization, and arc flash protection. Our VCPW medium voltage vacuum breaker would go into this standard or arc resistance switchgear, and our XGIS breakers would go into this gas insulated 38 kV switchgear.
Let's take a look at the components that make up typical circuit breakers. Here are the major components of a miniature circuit breaker. Notice the main components are the contacts, stabs, a handle mechanism, arc chutes, and more advanced ones have a circuit board with CTs. Here's a basic diagram of a molded case circuit breaker. These MCCBs have 5 basic components: an operating mechanism, arc extinguishers, contacts, a trip unit, and the breaker frame. The new Power Defense MCCBs add significant protection and monitoring capabilities with their new trip units. Low voltage power circuit breakers have many more components compared to the MCCBs and may be electrically operated, meaning you can turn them on and off remotely. This is possible because of the stored energy in the operating mechanism. As we mentioned before, they can also use a variety of trip units to enhance protection and safety. Modern medium voltage breakers use vacuum bottles as the mechanism to break current during an overload or fault condition. The components are similar to the low voltage power circuit breakers, except the vacuum bottles replace the arc chutes and contacts. Protective relays provide tripping logic for medium voltage breakers. For low voltage and medium voltage power circuit breakers, in order to close these breakers, springs must be mechanically charged either manually or electrically via this motor that looks like a drill motor. Note that the opening springs charge with the motion of closing the breaker so that it's always ready to trip. For example, if it's closed into a fault condition, you can always open the breaker, but you have to charge the breaker to close it.
So where are circuit breakers installed? Miniature circuit breakers are installed in residential load centers and commercial panel boards. Typically, molded case breakers are the main breakers for panel boards and maybe the feeder breakers in larger panel boards. Switchboards generally use MCCBs, and power breakers are used in low voltage and medium voltage switchgear. Busway uses molded case breakers in commercial and data center applications. Motor control centers use MCCBs for the main breakers and a special type of circuit protector called an HMCP as part of the motor starter. Utilities often use medium and low voltage switchgear with power circuit breakers. In addition, they use circuit breakers with a different form factor on their distribution circuits. They use vacuum reclosers, which are just vacuum breakers in substations or on a pole, and vacuum fault interrupters, or VFIs, inside substation and distribution transformers. Essentially, the VFI is a vacuum breaker that uses an external relay for protection, but is installed inside the transformer tank. What ratings are important when deciding what circuit breaker to apply to your system? The basic ratings include handle rating, frame size, sensor or plug rating, short circuit current rating, applicable voltage, and for more advanced breakers, trip functions and settings. Low voltage power circuit breakers have another rating called short time withstand. In addition, you need to consider the ANSI, NEMA, and IEC standards applicable to your application. The handle rating is generally considered the breaker size or the maximum continuous current rating. In many applications like your home, some miniature and molded case circuit breakers are rated at 80% of their handle rating once they're installed in an enclosure. For power circuit breakers and MCCBs, frame size is the maximum continuous current rating, but these breakers use a plug or sensor rating that either matches or reduces the maximum operating current rating. As an example, a 3200 amp frame breaker may have a 2500 amp rating plug, making the breaker effectively a 2500 amp breaker. The short circuit rating is the maximum allowable fault current that the breaker can handle without being damaged. If the KA rating is exceeded, the breaker may not function properly or may fail to clear the fault current. As an example, some miniature breakers may be rated 10 KA, MCCBs might be rated 35 KA, 65 KA or more, and some power circuit breakers are 100 KA or more. The arc flash reduction maintenance system, or ARMS protection setting, allows you to quickly de-energize the circuit breaker to substantially reduce the arc flash energy, protecting your people and equipment. The applicable standards for circuit breakers are UL 1066 for power circuit breakers and UL 489 for insulated case and molded case breakers. The IEC standard for circuit breakers is IEC 60947-2.
There are a number of circuit breakers that are used in special applications that are slight variations of standard breakers. We will discuss a few here, specifically HMCPs, supplemental protectors, AFCI and GFCI breakers, and DC breakers. HMCPs are a special breaker used in motor control centers. These motor circuit protectors offer only instantaneous fault protection, but do not have an overload protection like a normal thermomagnetic breaker. When an HMCP is used with a motor starter, the starter provides the overload or thermal protection, and the HMCP provides the fault protection. Supplemental protectors are often used as a circuit breaker inside industrial control equipment. Most people believe that these are standard breakers, but they're not. The UL 1077 standard defines a supplementary protector as a manually resettable device designed to open the circuit automatically like a breaker, but with limited short circuit protection. They provide protection for only one device, and they're always located after the branch circuit protection. Arc fault circuit interrupters, or AFCIs, and ground fault circuit interrupters, or GFCIs, are typically plug-on miniature circuit breakers that offer arcing fault protection and ground fault protection in residential applications. The NEC requires almost every circuit in new residential applications to either have AFCI, GFCI, or both protections on every circuit in a home. Another special application for breakers is DC circuit protection. DC circuit breakers are specially designed to break DC currents, which is more difficult to break than AC current, since DC doesn't have the zero crossings like AC. Power defense breakers add a whole new dimension to circuit protection. Power defense is made up of 6 frames, all globally rated to service our customers in every major market across the world. They range from non-adjustable to very advanced molded case breakers. The more advanced PXR trip units add power monitoring, waveform capture, and even functions found in advanced protective relays. These power defense breakers change the game and are loaded with features to maximize safety, reliability, and efficiency in any system.